In the last lecture, we have discussed the logical operator, implication, or conditional statements. In this lecture, we will discuss the topic biconditional statements. Consider two propositions P and Q. These two propositions can be combined by using the connective if and only if. By using this connective, we can combine these two propositions to obtain a new compound proposition P if and only if Q. So, by combining these two propositions by using this uh, connective if and only if, we will get a compound proposition P if and only if Q. This statement is called biconditional statement or by implication. By implication or biconditional statement. Okay, and it is denoted by this symbol. Okay, denoted by this symbol. Now, this biconditional statement or by implication is actually a combination of two implications, or it is a conjunction of two implications, which are P implies Q and Q implies P. Okay, so this biconditional statement is a combination of these two implications. That is, P if and only if Q is actually equal to P implies Q conjunction Q implies P. Okay. Now we have the definition of biconditional statements. Two propositions P and Q can be combined using the connective if and only if. The resulting proposition P if and only if Q is the conjunction of two implications which are P only if Q and P if Q. That is, P only if Q means Q if P, right? That is, this is P if Q and this is Q if P. That is, P implies Q and Q implies P. Okay. Accordingly, it is called a biconditional statement. It is symbolized by this symbol P if and only Q. Clear? For example, consider the propositions P is a proposition triangle ABC is equilateral and Q is the proposition which is triangle ABC is equiangular. The proposition P is triangle ABC is equilateral and triangle Q is triangle ABC is equiangular. Then what about P if and only if Q, which is nothing but triangle ABC is equilateral if and only if triangle ABC is equiangular. Okay, so this is the as an example. Okay, note that here also we can use more than one terminologies to express P if and only if Q. That is, for if P if and only if Q, we can use these terminologies. First one is P if and only if Q. Another one is if P then Q, and conversely. If P then Q and conversely. Third one is P if and only if Q. Fourth one is P is necessary and sufficient. Necessary and sufficient for Q. Okay. അതായത് ഈ പി ഇഫ് ആൻഡ് ഓൺലി ഇഫ് ക്യൂ എന്നുള്ളതിന് നമുക്ക് ഈ നൊട്ടേഷൻസ് എല്ലാം അല്ലെങ്കിൽ ഈ ടെർമിനോളജീസ് ഒക്കെ ഉപയോഗിക്കാം. പി ഇഫ് ആൻഡ് ഓൺലി ഇഫ് ക്യൂ, ഇഫ് പി ദെൻ ക്യൂ ആൻഡ് കോൺവേഴ്സ്ലി. ദാറ്റ് മീൻസ് if P then Q and if Q then P. That is what is this. Okay, and P if and only if Q, P is necessary and sufficient for Q. All these have same meaning. Okay, now we can create the truth table for P if and only if Q. Okay, now suppose P and Q are the proposition. So to find the truth value or truth table of P if and only if Q, first we can consider the truth value of P is T and the truth value of Q is also T. Then we know that the truth value of P implies Q is T. Okay, from the previous lecture we know that this is T, and correspondingly what will be this. So we can first write this. So when the truth value of P equal to T is T and the truth value of Q equal to F, then we have the truth value of P implies Q is nothing but F. Okay, and when truth value of F is truth value of P is F and truth value of Q is T, then we have the truth value of P implies Q is T, because here is F. If F, then if P, then Q. That is, F is P is false, therefore the truth value is T. And then now if the truth values of P and Q are F, then the truth value of P implies Q is T. Okay, this is we already discussed in the previous lecture. Now similarly we can write the truth values of Q implies P. So here we know the truth value for P implies Q is F only if this case Q is F and P is T. Okay, so now what about the truth value of Q implies P? So here we have uh, Q implies P means Q is T and P is T, therefore Q implies P is also T. Okay, now Q has the truth value F and P has the truth value T, therefore the truth value of Q implies P is also T. Now the truth value of Q is T and truth value of P is F, so truth value of Q implies P is false. Okay, now truth value of Q is F and truth value of P is F, therefore the truth value of Q implies P is T. Now we have P if and only if Q is nothing but P implies Q and Q implies P. Right. So the truth value is given by when P equal to the truth value of P is T and truth value of Q is T. Then what about the truth value of P if and only if Q? That is P implies Q and Q implies P. So the truth value of P implies Q is T and truth value of Q implies T is P is T. So we have the truth value of this their conjunction is also T. Okay. Now the truth value of P implies Q is F, truth value of Q implies P is T. Therefore, the truth value of their conjunction, that is truth value of P plus Q and Q plus P is false, because it has the P implies Q has the truth value F. And now if the truth value of P implies Q is T and truth value of Q implies P is F, therefore the truth value of P if and only if Q is F here also, because here we have F and we have the P if and only if Q is P implies Q and Q implies P. Now P implies Q is T, Q implies P is T, therefore P implies Q and Q implies P has the truth value T itself. Okay, so this is the truth value of P if and only Q. Now we can discuss a problem. The problem is, let x, y and z be any real numbers. Represent the sentence x greater than or equal to y and y greater than or equal to z if and only if x greater than or equal to z. Symbolically using the following propositions. P x less than y, q y less than z and r is x less than z. So here we are given three propositions P, Q and R, and by using this proposition we need to represent this sentence symbolically. Okay, we have to, our aim is to represent this symbol symbolically, this sentence symbolically by using these propositions. Clear? So here our sentence is x greater than or equal to y and y greater than or equal to z if and only if x greater than or equal to z. So here we are given that p, the proposition p is nothing but x less than y, but here we need x greater than or equal to y. Therefore since we can write like this, since p, the proposition p is x less than y, we have uh, negation p is nothing but x greater than or equal to y. Clear? So this x greater than or equal to y can be replaced by this symbol negation p. Now next is y greater than or equal to z. Here also we have q is y less than z. So in a similar way we have since what q is the proposition y less than z, we have we need y greater than or equal to z. So here we y less than z. Therefore negation q is nothing but y greater than or equal to z, and then we have x greater than or equal to z. So here we have x less than z is r. So in a similar way we can write, since the proportion r is x less than z, we have what, negation r is nothing but z greater than or equal to, sorry, x greater than or equal to z, x greater than or equal to z. So we have obtained x greater than or equal to y, y greater than or equal to z, and x greater than or equal to z. So our required sentence is nothing but so the required symbol of this sentence is nothing but the sentence is x greater than or equal to y and y greater than or equal to z if and only if x greater than or equal to z. So by using these notations or symbols, we can write this as x greater than or equal to y is uh, negation p. This is negation p and y greater than or equal to z. That is, and y greater than or equal to z is nothing but negation q. If and only if x greater than or equal to z, x greater than or equal to z is nothing but negation of r. Clear? So this will be the notation or expression of this sentence in symbolic form. Okay, negation p and negation q if and only if negation r. Okay.